Alright, I'm recording this for those who are absent so I can put it on my website. So, please follow along so we can get through this as fast as possible. I'm going to help you. Okay, these are guided notes. Instead of you writing them all, I typed some up for you. Okay, we're just going to go through them in order. A conditional probability is, see the new box? There's number 1 and number 2. Number 1 we talked about last time. Number 1, we talked about if two events were, notice it says on the right, independent, then the probability of A and B, and we talked about the word and means what operation? Multiply. So you can see here, probability of A times the probability of B is how you get probability of A and B. Now, if the two events are not independent, raise your hand please if you can tell me if they are not independent, what's the word we have for that? Victoria? Dependent. Okay, so if they are dependent, then we have a different situation that comes up. Probability of A and B when the two events are dependent is different. It's the probability of A times the probability of B. See this vertical bar? That's red given A has already happened. Probability of A times probability of B given that A has already happened. That's what we're working with today, is this thing right here. That's a conditional probability if you're finding the probability one event will happen given that a second event has already happened. Okay? So in the space below, if we're looking for the probability of A and B, looking for the probability of A and B, it equals the probability of A times the probability of B given A. Okay, we're going to solve the conditional part. So we have the formula which to find conditional. Yeah, you would actually divide because this is times, right? So we're going to divide by P of A on both sides. So essentially, if you look down here, oh, that one's in reverse order, so we'll put it right here. B given A will equal, on the left-hand side, we have it right there, probability of A and B divided by the probability of A. Now, the order at which these letters come is important. Here it says probability of B given that A has already happened. Notice the denominator. A is the given, so we always divide by the given. Again, this formula is for a conditional probability because it's conditional on this event A has already happened. Okay, a probability that takes into account that a condition must be met is called a probability, is a conditional probability. Alright, A means that we're finding the probability of A, oops, I should use capital A, of A happening given, I just scribbled it out because I didn't erase it, I messed up. Yeah, make it better. Of event A, better. Probability of event A happening given that event B has already occurred. Probability of event A happening given that event B has already occurred. Look at the difference. This one, what's the order of the letters? Probability of B given A has happened. Is that how this one is?
No.
Yeah, exactly. A given B has happened. So make sure you carefully look at the order because that will change the scenario. Down below we have the formula written out for us. Now on the side, I'm going to write the other one. This is A given B. So notice the B is your divisor. If we reverse it, B given A, we always divide by the given. The numerator is always the intersection and, but in this case, this one handwriting, what's the given? A. So in this case, we divide by A. So these are reversible of each other, right? Well, we just switch the order. However, as we will show in an example coming up, just by reversing them, you don't get the same result. So would you like to note that compound probabilities? Can't put that. Compound probabilities are usually not reversible. So the probability of B given A usually will not, there'll be a rare occasion when it works, but, you know, a good percentage of the time, the majority of the time, just reversing the order of the conditional probabilities will give you a different probability result. So they're not reversible. Okay, so we're going to do an example to hopefully sink in what all this is actually meaning. Example. In New York State, as you read story problems, you should underline anything that sounds important. 48% of all teenagers own a skateboard. Anything that important? Yeah. And specifically, what does 48% go to? Skateboard. Teenagers who own a skateboard. 39% of all teenagers own what? And rollerblades, right? 39% of all teenagers own rollerblades. Okay, we're going to find the probability that a teenager owns rollerblades given, there's that word given, given, what is our happen? Given which group of people? What is it, Alyssa? Who own skateboards. Okay. The probability that they own and then we use this vertical bar for given, and Alyssa told us the given is that they have a skateboard. I think I need to zoom a little better. Okay? I wonder if it will let me. Okay. So, conditional means we're no longer looking at the 100% of the population. Victoria, what percent of the population was the skateboard population? Do you agree? 48% have skateboards?
Oh, yes.
Yes. So we're no longer looking at 100%. Now our denominator is 48%. And then remember the division is, because again here is the formula, the division, the numerator is the intersection A and B. So what percentage have a skateboard and rollerblades? 39%. So you should have all got calculators. Looks like most people have them. We need 9 divided by 0.48. There's 4 numbers, right? 4 numbers? Choose 5. Now, it can be written in 3 ways: fractions, percents, or decimals. For me personally, I like the percent because it makes more sense in my head. 81.25%. He's not here. I'm sorry, you have a question? Yeah. To the right. Yep. Okay, so remember, this is not 81% of all teenagers in New York State have a skateboard. Or just have rollerblades. It's 81% of teenagers have rollerblades, given that we already know they have a skateboard. So it's not 100% of the population anymore. It's only a select 48%. Okay, we can also do conditional probabilities, which I think is actually easier, with the two-way table. Two-way tables have rows and they have columns, and it's just a way to organize the data. So at the bottom here, let's write some notes. So how does this work here? To find a conditional probability using a two-way table, so use the intersection. And I learned yesterday that apparently you guys haven't been taught what that means. Okay, so we're going to write 2 rows here. You have room at the bottom, right? A quick Venn diagram, A and B. If I'm looking for the probability of A and B, where's the and part on the diagram? Where they overlap, right? Okay, this overlapping is called an intersection, which makes sense, because when 2 streets overlap each other, don't we call that an intersection, where the traffic light is? And there's an abbreviation for and. Sometimes you see it as A and then it's upside down, U, A and B like that. And it means one way people say it. A intersect B. Or A and B. The and is the intersection. And the abbreviation for that is, or the symbol for that, is an upside down, like horse. Okay, the other one is or. Now, last time we talked about mathematically, what do we do with or? Addition versus intersection, we multiply. Or can be that intersection, but it can also be what each circle brings to the table. All of A and all of B. So or is everything in A and B. And or has an abbreviation as well. And that is another word for or is union. And union starts with a U, right? Intersection versus union. Union. This can be read as A union B, or the union of A and B. So union, or that U shape, means or. Because if you think of, like, when 2 people get married, that's a union, right? Okay. Now, at some point, 2 people who get married most likely have some things in common. They have to have something to talk about, right? So that's the intersection. But individually, like the missus, maybe she likes watching HGTV. Interior design shows, House Hunters, my favorite. But the husband, stereotypically of course, might like watching ESPN. So they bring the individual things with them, but they also have an overlap and union. I don't know, it's just a word. Okay, so let's look on a two-way table. Flip it over. This is what a two-way table is. You look at table, the rows are male and female. What's in the columns? Candy, chips, and fruit. So maybe it's people's choice of a snack for lunch, candy, chips, or fruit. Most people don't pick the fruit. If you look, would you pick the fruit?
Yeah.
If it was breakfast, I would pick the fruit. But candy, chips, or fruit. Okay, so we're going to look at all these probabilities and look at the conditional probability. First of all, what's the probability, number one, that if we picked a person at random from the selection of people, that we get a male? Parker, what do we get? Yeah, because there's 100, you look at the male row, there's 118, and there's a total of 250 people. Now we're going to practice simplifying fractions on our calculator. So if you could please take 118, divide by 250. Do you remember how to simplify a fraction? Math, and then what? Enter, enter. Math, enter, enter. Jared, math, enter, enter. Okay, Susanna, what did you get when you did math, enter, enter? What did you? I think you might have mistyped. Yeah, I got 59. If you do the division, oops, I put an extra button there. Approximately what percent? Good. 47% of this collection of people are male. Okay, now number two. We're going to find the probability that they're not only male, but they also got chips. It says and right here. So that's when you take the row and the column, find the male row, find the column of chips, and what number's in there? 62 out of how many total? 250. What you just said will actually be on number 3, I believe. 250 is the total. It's not until we get to a conditional where we have that given piece that we change the total value. Okay? Just if you see this vertical bar like on number 3, that's when you go to the 108. Okay? So 62 divided by 250. Teddy, can you simplify that for me?
24.
5%. Okay, who has a simplified fraction? Yeah? Number 3 is a conditional. So that vertical bar means the male given they already selected chips. So when it's conditional, what's the given group? Chips. In the chips column. How many of those chips, people who got chips, are male? Out of how many total? Okay, 62 out of 108. Any questions how I decided to do 108 instead of 250 or other questions? Okay, let's simplify this. And Cynthia, if you could tell me the simplified form, please. Good. And do you have the percent? Approximately 57%. And this isn't 57% of all people. It's just 57% of the ones who got chips were male. So it actually tells you more men, out of people who selected chips, more men selected the chips, right? Only 43% of those who got chips were female. Okay, number 4 is the order. It is changed. Okay, Shay, what's the given on number 4? Given, which one's the given? It's the last one after the bar. I'm not being very clear. See the bar? What word comes after the bar? What word comes after the bar? Male. That's our given category. So I'm going to, looking not at the first word, you jump to the second word. I'm going to highlight the given. In male, Gerardo, what's the probability that they grabbed chips given that they were male? Out of? How many males are there? 118. Okay, look at the difference between number 3 and 4. They both have 62, but do their denominators match on 3 and 4? No. So this is why we wrote that reversing the conditional statement does not give you the same answer all the time. Usually it actually doesn't come out. So this one would be 31 out of 59, or the other percent. Thank you. Okay, I want you to try two on your own actually. Numbers 5 and 7. We're skipping. Stand up please when you have the conditional probability simplified for 5 and 7. 5 and 7. Excuse me, sorry. Screws with me. Forward. Okay, 5 and 7. Okay, am I on? All right. So, number so you should have done, there are 15 males out of 35, not 118. Who did that?
I did that.
Okay, the rest of you, can you fix it? It's out of the total 35, which simplifies to 3/7 or 43%, I think. Okay? Ooh, I'm out of time. Male. I'm just going to write it down here. Fruit, given that they're male, here's the male. How many of those people on this line got fruit? 15, and what's the total on that line? Good, and I don't have that simplified. Actually, it doesn't simplify, does it? What's the percentage?
30%.
Great. Okay, we're going to skip 8 and 9, but let's at least do number 6. Remember this C? We talked about this when we did probability. You can also see this as if the event is A prime, or not A, or tilde A. So it means everything outside of males. Okay, so find the probability that they're not male. Well, if they're not male, that's what that little C means, not. The complement. They're not male, what are they? Female. So we know that, we already know that. So what's the probability that they're female? 53%. Okay, so this is a two-way table to do conditional probabilities. It's nice because it already has those numbers lined up for you. Let's quickly look at a Venn diagram. Okay, you need to close the circle that didn't get printed right there. We can do this really fast. Probability of A. Well, are there two values in A? Yeah, so in total, how much is in A? 0.5. So it's actually 50% right there, right? Probability of B. Well, actually two values in B. Oh no, it's actually 0.20 plus 0.35. 0.55. Now the intersection is just this area, which is 0.2. Notice I said the word intersection because that's and. Gerardo, are you with us?
Yeah.
Let's quickly do the conditionals on 4, 5, and then the or on 6. Alright, the probability of A given B. I try to underline the given part every time. Given B. So I go to the given first. So this is the only area we're looking at. How much of that is in A? 0.2 divided by B, which was 0.55. You always divide by the given. Can someone divide that for me? So about 36%. Okay, now 5 changes that. What's the given on number 5? A. So I'm going to circle A. That's the only area I'm looking at. B given A. How much is in B, given that it's already in A? 0.2 divided by the given. The given, we already know, 0.5, which is 2/5, 0.4, or 40%. Okay, and lastly, A or B. That means it can be in A, plus it can be in B, plus the 0.2. Which 0.30 plus 0.35 plus 20 is 0.85. Okay, so we'll stop there. Now oops, where did I put my little green paper? Good homework. And remember, next time we'll be meeting at the library for the SAGE test. Oh, here it is. The homework. Page 965, 2 through 14 even, 17 through 19. Those are conditional probabilities. Two-way tables and conditional probabilities. It says even, so it's not as many as it looks like. Carlos? No. Where's the 21? This is a comma. Even. Sorry, my sloppy writing. I'll try to write neater. 2 through 14 even, 17 through 19. After the SAGE test, you will be turning in that review that we did today. So please do not lose it. I'm letting you keep it so that you will have it available to hopefully look at